So we have tan x plus pi over 2 is equal to 1. We said if there's anything there that is not just x, then we'll say let theta be equal to x plus pi over 2. So that we deal with tan theta is equal to 1. Now we know that theta should be 45 for us to get that, meaning that theta should be pi over 4. Now that I have pi over 4, I know that tan is also positive in the third quadrant. So in the third quadrant, to get theta here, you say x, you say 180 plus 45, which is pi plus pi over 4. So we have 5 pi over 4. So theta also is 5 pi over 4. So x plus pi over 2 is equal to pi over 4. This means that x is equal to pi over 4 minus pi over 2, which is pi minus 2 pi over 4, which is negative pi over 4. This guy is outside the required range. So we got the next x pi over 2 is equal to 5 pi over 4, which is equal to x is equal to 5 pi over 4 minus pi over 2. This is 5 pi minus 2 pi over 4, which is equal to 3 pi over 4. We're dealing with 45 in the first quadrant there. So if we went round and gone as far as 360 plus 45, we would get, what do we get? 305, 405, I mean. Then you come and say x plus pi over 2 is equal to, okay, let me use 90, since pi over 2 is 90, is equal to 405. So x is equal to 405 minus 90. You'll see that what we are getting here is that's 85, so that is 315. Now 315 is bigger than 360. This guy is bigger than 180, I mean. Remember, the required range is from 0 to pi. So the only solution that we have here is x is equal to 3 pi over 4. So we could have gone as far as how many circles, depending on the interval given and what we have inside as x plus something. That time it was 3x. We could go around. When we divide, you still get between 0 and 180. But now it's addition. You try to go around, you get a number that is outside 0 and 180. So you forget about those numbers. Then we have forgotten about this number here because it's a negative value, but we just want from 0 to 180. So whatever is outside that interval, we forget about it. So we go to question 7.
Sir.
Hello.
Yeah, before you proceed, sir, this solution which has got a negative sign, what will happen if you leave it out? Can they, is it given a mark, or if you have left it out, it's okay, but you just write that, which is the answer, which is 3 by 3 pi over 4.
That thing must show in your working. And you
Okay.
must also indicate that the only solution you have is x is equal to 3 pi over 4.
Okay.
Yes. The next question, for values of x between negative pi over 2 x and pi over 2. We are now dealing with negative 90 to 90. Sketch the curves on the same axis. The curve y is equal to 0.5, which is half, minus sine x. Sketch the curves on the same axis. You also have another curve, which is y is equal to half plus cos 2x. So start with the first one. Curve is on the same axis. The previous screen is here.
All right, thank you. So you can proceed.
I'll proceed. Okay, so for the first y, this one here, we get a period is 2 pi. The scale is 2 pi over 4, which is pi over 2. So it's enough. Having the period and the scale there is enough. So from 0, we'll go to pi over 2, and the left negative pi over 2. Since you are given that as our interval there, there's no need of adding other numbers. We just end there and then go to that curve. Y is equal to half minus sine 0. That is at 0 there, so we'll get just half. So we have half. We have a point there. Second, the screenshots that you take, I can as well send you the PDF if you asked for it. But since you're taking screenshots, I won't send it because you already have it. So we get half, then we got the next one, y is equal to half minus sine 90. There's a question from Chola.
No, sir, it's fine.
Okay, so sine 90 is 1, so we get half minus 1, which is negative half. So we have negative half. So we get this thing here. So what we are having now is, oh, so the point has been mislabeled. Okay, supposed to be 90, comma that guy, comma half, negative half there. Okay, then we also have another one, y is equal to half minus sine negative 90. Now sine is an odd function. It takes away the sign as it is. So we have half plus 1, giving us 3 over 2. So we have 3 over 2 as a point there. So 3 over 2 there. Okay. So next thing, we can draw the curve. So the curve is just something like this. For this one there. Then we got the other one. The other one is y is equal to half plus cos 2x. So let's get the period here. It's 2 pi over 2, which is the b. So our period is pi. So that our scale will be pi over 4. So we come here and write pi over 4. Not on the excuse, not on the graph, because we don't know if it is pi over 2 there. So we'll write somewhere here pi over 2.
I've got a question.
Please ask.
How are you identifying the periods?
So the period is 2 pi over b, given that y is a cos bx plus c plus d. So a cos bx plus c plus d, meaning that the b is always that thing which is multiplying the x. So if you have 2x, so the b is 2. If you have just x, the b is 1. Okay. So we have now put, after having the scale, we have fused in pi over 4 and negative pi over 4. Would have gone beyond, but we are told it must be between negative 90 and 90. So now we substitute y is equal to half plus cos 2 multiplied by 0, which is half plus cos 0. But cos 0 is 1, so we get half plus 1, which is 3 over 2. So at 0, we have 3 over 2 there. Then we also have y is equal to half plus cos at pi over, okay, let's get at pi over 2 now. At pi over 2, the end point multiplied by 2, remember it's 2x, so multiplied by 2. So you get half plus cos pi. Now cos pi is 0. Cos 180 is negative 1, not 0. Yeah, so 180 is negative 1. So we get half minus 1, which is negative half. So at the point there, negative half. So that at pi over 4, let's see at pi over 4, y is going to be half plus cos 2 pi over pi over 4. So we get half plus cos pi over 2. Now cos pi over 2 is 0. So would have gotten half. Okay, so it's half somewhere here. And so the other side will be the same point. So here to be somewhere there and here down there. So this graph is coming down here. Also going down there. So why do I say it will be the same? Because y is equal to half plus cos 2 by negative pi over 4. still gives us half plus cos pi over 2. Since cos is an even function, it chooses the negative. It does not send it outside. It neutralizes it to make it positive. Okay, so what was the other question now? We have sketched them. We also have another addition here. Obtain the coordinates of the point P at which these curves meet. The first coordinate is here. They meet here. They meet at x is equal to pi over 2 and y is equal to negative half. So the point is pi over 2 comma negative half. But we can also solve to find this point because we need the other point here. So how do we solve? You equate these. Since they are all equal to y, they must equal to themselves. Meaning that half, they must be equal to each other. Half minus sine x is equal to half plus cos 2x. So the halves will go. You remain with negative sine x is equal to cos 2x. Remember, in the first PDF, in the first class for today, cos 2x was found as cos squared x minus sine squared x. You must always keep this wherever you are. And keep this thing until December. Yes. Yes. Okay. So when sine or cos, if they are all there in that equation and one of them is not squared, the one which is not squared should be reserved. Then go to the other one, change it using this identity to the other form. Now sine is not squared, so we change cos into sine. So we'll say cos squared x is equal to 1 minus sine squared x. So that here we have negative sine x is equal to 1 minus sine squared x for cos minus sine squared x. So that we have negative sine x is equal to 1 minus 2 sine squared x. So we can take everything to the left so that we have 2 sine squared x minus sine x minus 1 is equal to 0. What does this mean? This means that we have a quadratic. We can let p to be sine x and freely solve this guy here as a quadratic with a product being equal to negative 2, the sum negative 1, so that the factors negative 2 and positive 1. So we have 2p squared minus 2p plus p minus 1 is 0. Factor out 2p, get p minus 1. Factor out 1, get p minus 1 is 0. So that p is equal to 1 and p is equal to negative 1 over 2. Now when p is 1, it implies that sine x is 1. At which value of x do we get that thing to be 1? At x is equal to 90. When is x equal to 90? X is 90 when you have 1 this side. So we are done there. meaning we have answered this part here. Okay. If we didn't know, this is if we didn't know that it was together there, that there they meet, you would have still gotten it using this equation here. We also have sin x is equal to negative half. Negative half, where in the third and fourth quadrant, we get sign to be negative. So this means that if we forget about the half, if you deal with sin x is equal to half, you'd observe that x is 30 pi over 6. But 30 is in the first quadrant where sign is positive. So we need to go in the third quadrant, and the fourth quadrant. But what we want here is an angle that is between 0 and negative pi over 2. So you go to the fourth quadrant, start from 0, go to negative pi over 2. If you move in reverse, the angles move from 0 to negative 90, then to negative 180, then to negative 3 pi over 2, then to negative 2 pi, like that. So in this case, what we are having here is a negative 30 here is a negative pi over 6. So x is negative pi over 6 because sine negative pi over 6 would be the same as negative sine pi over 6, which is the same as negative half. So the angle required, the value of x required is pi over 6 negative, as y is negative half. Is that true? Let's go check. So let's substitute this guy in the first equation. Y is equal to half minus sine pi over 6. Negative, remember it's negative. So have half plus sine pi over 6, meaning half plus half will get 1. So this guy here must be 1. Okay. Let's see if the second one also gives us 1. Y is equal to half plus cos 2 pi over 6 negative. So we have half plus cos pi over 3. Now what is cos pi over 3? That is cos 60. Cos 60 is half. So we get 1. So where they are meeting here, supposed to be pi over 6. So this guy should be a bit inside. So this guy should be a bit inside, negative pi over 4. Because here, we are saying that it's pi over 6 negative. This one is 4. So that we are saying now, we have found the values of x where they meet. So in terms of points, because we've been told that we should get them as coordinates, as coordinate points. Obtain the coordinates of the point P at which they meet. So the first one is, where is the first one? From here, okay, I'll put them here. The first point is negative pi over 6, comma 1. The second point is pi over 2, comma negative half. Okay. So we are done. We have found our 2 points. Okay, this was question 7. You can move to question 9. Question 8.
Yes, sir.
Question 8. Question 8. Sketch the graphs of the following for 0, less or equal to x, less or equal to 360. So we've been given now the range in degrees, so we must sketch in degrees. 1. Y is equal to negative cos x. Remember we said the general form should be A cos bx plus c plus d. So whenever you are given whatever you are given, you compare to this for you to be able to get the period, which we said should be 2 pi. Now when you're dealing with degrees, 2 pi is 360, so you say 360 over b, but in this case we have 360 over, our b is 1, so we get 360. So we get that. Then the amplitude is the modulus of A, which is the absolute value of -1, which is equal to 1. And then once I have the period, I can get the scale, which is the period over 4. So we'll have 360 over 4, which is equal to 90. The vertical shift is 0. Horizontal shift is 0. So we can sketch. So we have 0, we have 90, 180, 270, 360. So I don't care about the amplitude part here. All I will do is I'll get y and evaluate it at 0. So you know cos 0 is 1, so I'm getting -1. Four is coming from these critical points, 1, 2, 3, 4, excluding 0. That's why we use 4. Because we have 4 critical points, 2 turning points and 2 intercepts. Okay, so we have found 0, -1. So we have a point here. From there, we also have y is equal to negative cos 90. Now cos 90 is 0, so I have -0, which is 0. So we have a point there. We also have y is equal to negative cos 180. Cos 180 is -1, so we get 1. So we need a 1. We have a point here. Then y is equal to negative cos 270. But cos 270 is 0. So you have -0, which is 0. A point there. Then y is equal to negative cos 360. Cos 360 is 1. So we get -1. So we have a point down here. So we can sketch something that looks like this over graph. Supposed to pass at the point here. So this is so that is our point. Undo this one here. is our point. This guy. Okay. Yeah, that's 270 there. So that's how the graph of that goes. So to avoid issues of memorizing, that's how graphs should be coming out. Do we have questions?
Hello, sir.
Yes.
I have a question, sir. Isn't cos a cos function an even function, whereby negative cos x will be just the same as cos x, the normal function?
If there's no, no. That won't be the same. Negative cos x is not sin x, but the shifted cos x by 90 gives you sin x.
Sir,
Hello.
I don't know if you have got a suggestion. We're having class around 12 hours. I don't know if you can give us like 5 minutes to prepare for the next class.
Okay. Okay, where are you going to find these videos? I'll send it to, okay, your teacher will communicate. Have a good day.
Thank you.
All right,
sir.
thank
Thank
you.
you, sir.
Good day. We have enjoyed the class.
Thank you.
Have a blessed day. The class was lit.
They did litty.
Don't forget to send the video. Some of us didn't attend the first one.
Okay, tutor will send it.
Class.